Hi guys, welcome to Code Explode. Today we're going to be talking about another functional programming concept called immutability. We're going to look at a mutable program that has a bug, and then we're going to look at how this bug could have been avoided using immutability and functional programming. So let's get into it. Okay, so here we have a very simple program which simulates a shopping cart. At the top we have our cart, which is a list, and in Python a list is a mutable data structure. We then have two methods: add item to the cart and get the contents of the cart. This code here just calls these two methods. It first adds a banana to the cart and then it prints out the contents of the cart. So first of all, let's just check that this does work, and we can see that it does. Our cart now contains an item which is a banana. Now, say that we try to use this code from another part of the program. So someone, maybe another developer, writes in another place in the code base. He wants to use the code and he says, okay, well, I'll get the cart like this. Then I can see the format of the cart, so I'll append a new item like this. Now, this code does work. You can see that the cart now has two items, a banana and an apple, but there's a potential for a bug. Now, why is there a potential for a bug? Okay, I'll show you. So say that another developer came along and he wanted to update this cart code. So maybe he wanted to, say, add a price. So let's do that now. Then maybe he wanted to add a method to use that price. So, for example, maybe a method to get the total of the cart. So this method is just going to go through every item in the cart, every price, and sum it up. Okay, so let's comment out this erroneous code for now, and let's add a price for our banana, and let's print out the total using a new method. Let's check that this works. Okay, so it works. Our total is 10 because we've just got one banana which costs 10. Okay, so let's put this erroneous code back in and run the program again. Now you can see that we've caused a bug here because this append here did not include the price. So it worked when he wrote the code, but then when we updated this cart code, it didn't work. It would have caused a bug in the program. And we allowed them to cause this bug because we used a mutable data structure. So now I'm going to show you how you can use an immutable data structure to avoid these kinds of issues. So this is our immutable code. It's very, very similar, apart from we're not holding the cart contents with these two functions. These two functions are pure functions, i.e. they don't rely on any external state. They only rely on the values that are passed in. So we have two methods: create a cart, which returns a tuple. In Python, an open close bracket is a tuple. A tuple is an immutable data structure. A list is a mutable data structure, so this is now immutable. When we add an item to the cart, instead of adding the actual item to the list of items, we don't actually add the item to the cart, we create a new cart with all the previous items plus the new item. That's what this code does there. So this is the code that uses this new API. So this creates a new cart called my cart. This adds our banana in, and this prints the contents of my cart. So let's check that this works. Okay, it works. So now what would happen if we tried to rewrite our erroneous code that broke our last shopping cart? So if I say my cart dot append name. Okay, what happens? So we've just written the code and then we tried to run it, and we can immediately see there's an error because the append function does not exist on a tuple object because it's immutable. So we've avoided this kind of bug through immutability and functional programming. So that's my video on immutable data structures. I hope that you enjoyed it. I hope that you got something from it. If you want to like it, please do. If you're not, no worries. I'm just happy people are watching it at this point. So thanks so much for watching, and I hope to see you again very soon.